cytokine antagonists. Now, these are interesting, I guess I would call them a phenomenon in the field of immunology. There's two ways that you can have an antagonist to cytokines. Either you block the cytokine itself by binding to it and thus altering the active site that it would bind to, or you would bind to the receptor itself. Now, a lot of these have come up in viruses, so you can look at table 12-3 to tell you about some of the viral mimics of cytokines and their receptors. So a lot of times viruses, if they're infecting a cell, one of the things they want to do is to upregulate the production of those cells, because they're just like prophages. They're inserting their DNA into the genome of that cell. Well, the more times that cell replicates, the more likely it is that some of those viral offspring, it replicates the viral DNA along with it. Some of those viral offspring will just continue, and thus it increases the number of viral particles. So quite a few of these viruses have developed mimics of either the cytokines or the homologs. So you want to read through that section. Now, the ones that are most effective at blocking the effector functions of cytokines are the ones that will bind to the receptor, mainly because you do have that redundancy mechanism in cytokines, and you can have multiple different kinds of interleukins that can bind to similar receptors. So by blocking the receptor without activating it, then you've technically blocked all of the different types of cytokines that could possibly bind to that particular area. Now, sometimes I just go blank. So you read through this section. It's not that long of a section. You don't have to get into the different types of cytokines that are secreted by the T helper cell subtypes that are in there, but read the one section on cytokine antagonist, and there will be a couple of questions on this section, so dig into it a little bit and try to think about it. I'll move to the next section.